Well, good morning, good afternoon, good evening, whenever you're listening to this. Welcome to the show. My name is Seth Earley.
And I'm Chris Featherstone.
And what I'd like to do is introduce our guest. We're really excited, and we're going to talk about many of the misconceptions around AI and generative AI. We always talk about misconceptions. We're going to talk about retrieval augmented generation, which of course is the thing that people think is the next best thing. Of course, there's good reason to think about that. We'll talk about some of the nuances of RAG. Our guest today is a renowned expert in artificial intelligence and data science. He has a unique background that includes economics. He started his career as an equity trader on the New York Stock Exchange and transitioned from using Excel to do his data-driven decision-making to mastering advanced data science techniques with Python and R. He has a deep understanding of statistics and advanced mathematics, and that coupled with his practical experience really propelled him into the world of AI because that was an ideal background for that. Currently, he is head of AI at STX Next, where he leads AI strategy and implementation for a range of innovative projects. Bartek Roszak, welcome to the show.
Yeah, hi, Seth. Hi, Chris. Thank you for the introduction. It's great to be here.
So, Bartek, were all of those, it seems like you had, as an equity trader, building tools to help you trade faster, better, cheaper, stronger, whatever that is for you personally, or was it for the companies you're working for?
So, I would say both. Of course, I did it for I started as a trader for a proprietary trading company during my Excel time. And after I started doing data science, deep learning and stuff like that, I also worked for a hedge fund where I built autonomous traders. But also during my free time, I like to experiment with trading. Of course, I have my own trading strategies, rather long terms, and I use a lot of data science there. But yeah.
Maybe, Seth, we should get a offline tutorial from Bartek on our trading strategies.
I'm in index funds. That's it. I'm in index funds, long term. Buy, hold. I'm not a day trader. I would have.
That's a pretty good strategy that is really hard to beat, actually.
That or the Wall Street Journal has people throwing every year. They do the darts. Have you heard about that? Completely random, and their random dart throwing typically outperforms the market. Who can say well, or outperforms one of the more advanced gurus and star traders out there. But let's talk about the space that we're in, the Gen AI space, the AI space, and talk about what are you seeing in terms of your projects, your initiatives. When you talk to executives, either on the technology or the business side, what are the things that people don't understand, or what do they get wrong? And I know that's kind of evolving, right, as the industry matures, as people become more aware. But give me your thoughts on what the common misconceptions are.
So I think that in AI, especially in Gen AI, we have this common thing with the new things that are really hyped. So 1.5 years ago, we heard that prompt engineering is the next big thing. Then we heard that RAG is the next big thing. I think that I hear now that the multi-agent approach is the next big thing, right? So I'm curious what would be the next big thing after that. But definitely
RAG approaches with prompt engineering.
Yeah, of course. This is all actually the same stuff.
Yeah,
this is all the same stuff because we start achieving some better results with prompt engineering, but it was not enough. So we start doing RAG. After we do RAG, we see the limitations. So we start doing multi-agents and stuff like that. So it's like normal process of development, I would say, right? So basically, in terms of what I see on the market right now, so we have this huge hype. A lot of companies wants to do AI. Some of them are major in doing Gen AI. Some of them just started, and also a lot of companies started AI project that failed, and they don't want to now to invest more money to projects like that. But there's also a lot of great success in applying AI, generative AI, RAG, and multi-agent approach, and we see more and more companies that want to do the same, right?
So I got a quick question too, because we usually ask, Seth usually starts out the misconceptions, for AI and stuff. And I love the fact that you come from a deep data science background. Where do you think, kind of going up the stream a little bit, where do the data science teams miss in a lot of this? Or do you feel like
I
there's
think that the bigger, yeah.
yeah, sorry, go ahead, Bartek. Go ahead.
Yeah, the huge gap that I see now is it's quality assurance, right? So basically, in normal like software development, we have QA teams, and it's like pretty obvious that we need QA team that is separated from the engineering team to check how good, what is the quality of their work and stuff like that. But actually, we don't have good practices around AI, like around QA and AI. And I've seen a lot of AI projects that failed because they didn't have proper QA, because people who developed models were also the same guys who were evaluating the models, validating the models, and deploying models on production, right? So this is something that I believe is missing right now in AI, and it will change in the future. Even right now, like after I joined to STX Next like 1 year ago or something, the first thing I started to doing, I started meetings with QA team and saying to them that, okay, guys, you are great in software development QA, but you need to be good also in AI QA, because this is the next big thing in QA, I believe. And yeah, and now I start seeing like job offers like be machine learning QA engineer or AI validator. Yeah.
So you're talking about quality assurance, right? When you say quality assurance, and when you define quality assurance in AI or in data, tell me more what you mean by that. Because I read a post the other day by a chief information officer or chief data officer, and he went on and on about quality data. Data quality is important. Data quality, data quality, data quality, right? And yet it was very difficult to kind of understand exactly what data he was talking about. And he talked about training data. Well, training data can be interpreted in a lot of different ways. So when you talk about quality assurance and data quality and quality assurance of models and performance, tell me more of what you mean specifically. And then how does that fit in with the different data sources? So what do people need to do?
Yeah, so that's actually a really good question, because there's at every stage of AI development, we need some QA, and data is the first place where we need to apply some QA. And there's like a bunch of techniques. It all depends on the use case, but it could be, for example, checking distribution of new data, right? So if the distribution is the same that as we have in our history data, this is one thing that we can check, like missing data, checking missing data. How many missing data do we have and stuff like that? Because if we retrieve some real-time data, there always could be some I don't know, some interruptions, some bugs, and some changes in the data. We need to be alerted about it. We need to switch off models and stuff like that. So this is like a QA data part. Is of course it is much bigger, but just to give you some example. Then we have then we develop models, assuming that we have high quality data, historical data, as well as real-time data. It's good quality. Then we develop models. We can develop models with it. And after we deploy the models, we, like, even before we deploy the models, we need to validate this model. So there's a lot of things that can happen if you put data scientists to develop new models. They can by accident miss a lot of things. Like they can miss some data leakage. They can like overfit to validation set. They can do a lot of things, and even extremely experienced data scientists, deep learning engineers, researchers can do it. I've seen it many times. I did mistakes like this many times, even though I was like extremely aware of it, I would say. So validation models before we run on production is another part of QA. And the last part of QA is what we do after deployment stage. So our model, we are pretty sure that our model has high quality data. It was trained well because we check it, everything, and now we deploy it on production, and it should work well, right? But maybe there is something missing, and we need to monitor. The most common thing that we need to monitor is the output distribution. Like, there's of course more of it, but the most common is if we have, for example, prediction. If we have like classifier, we predict multiple classes. We should like put attention to what kind of classes we predict the most often. If this is like different than it was during training phase and stuff like that. So this is also like part of quality assurance, right?
So when you are talking about building a model, training a model, are you actually saying that you're retraining a foundational model? You're not building a model from scratch. Or are you talking about training as in what the model needs to access in terms of data sources? So how are you defining? Because training can be defined in a lot of different ways, training data.
No. What I said, it was more general approach to training machine learning models, not only like generative AI models, but any kind of machine learning models, I would say. So simply every time we use data to train models to make predictions on production, it was like general approach. But in terms of generative AI, the things are getting more and more complicated. Of course, we don't need to train the model. Maybe we want to fine-tune model, but this is not like this is a rather rare case. But at the end, we can have like really hard times to evaluate quality of our solution. If depends, it could be RAG, it could be just prompt engineering, it could be a multi-agent approach, but it's really hard to evaluate how accurate our solution is, right? Because if we would like to have system that is able to answer questions about our knowledge base, we have, I don't know, we have some informations about our company, internal policies and stuff like that, and we want to create RAG system that we can query with some information. And how we can check, how we can evaluate that our system is answering in correct way. We can create like evaluation set, correct question and answers, but it's not obvious. It's like we cannot like perfectly say that we have 80% accuracy, 90% accuracy. Sometimes model can give you right answer, but it will be different than the golden standard.
So we have golden use cases where we know the answers, but those are narratives, and the narratives can change. And so then we can use a large language model to compare those narratives and to provide some prediction of accuracy or quality.
Yeah, we can do it like that. Yeah.
So yeah, you have to kind of, or a human needs to look at them and say these answers are equivalent, right?
Yeah. Actually, my personal view is that we don't have like other good strategy than just manually check the answers. And because we would like to check the number that is statistically significant, it's really hard to evaluate model after each change, right? So we, of course, we use some automatic system. We use LLM to check LLM answers and stuff like that. But this is not like, I would say, perfect state.
Yeah, you need human curation. You need human in the loop.
Yeah.
For various validations. Now, going back to kind of the misconceptions, one of the things we talked about in our prep call was that people expect it to work. Like, tell me more about what you've experienced when it comes to Gen AI. And I think there was a little bit of naivete earlier in the market, and now that's kind of been replaced by a more sober-minded approach to say this. But tell me more about what people's expectations are, and then what you have to do to kind of mitigate or deal with those or manage those expectations.
Yeah. So of course, like expectations are high, really high, because like the information that we hear about Gen AI are so promising that expectations are at so high level. This is really hard to manage it. So basically our approach, because we never know if the Gen AI is really brand new technology, and we are not sure if it will work correctly with your data. We need to check it. So every time we start a project with Gen AI, we propose to do POC first. So quick, low budget project that will just show what kind of possibilities we have with Gen AI. So for example, if you would like to develop RAG system for your data, I would propose you to do it in like 1 or 2 months. Just deploy that like default version of the system, fine tune it a little bit, and just to check how accurate it is, just to give you to play with it, to check if this is enough for you. And after that, we will create a report, what kind of techniques we used, and what are our propositions what are our next steps that we should take, and what could be expected accuracy if we put more effort to it, right? Because if you would like to have like RAG system that is really accurate and you have complex data, it could take 1 year of like 2 or 3 engineers like doing fine tuning, researching, and making system accurate, right?
So talk a little bit about how RAG has evolved. So originally we were saying, well, ask your LLM for the answer, and the LLM would come up with an answer that may not be based on reality, right? So it would hallucinate.
Yeah.
And then people said, well, use a knowledge base. And then that but then that fell back on the challenges of any basic knowledge base. And what I saw initially were people just using full text search, keyword search. And that's going to be as good as your keyword search is today, right? If you don't have finely tuned content and you don't have things like thesaurus structures, or you don't have semantic search, or you're not using parametric search or whatever, it's going to be bad, right? If you have crappy content and you're using sparse keywords and ambiguous queries, it's going to be like search. It's going to suck like search sucks. And then we got into advanced RAG, so talk about naive RAG, advanced RAG, and then talk a little bit about what modular RAG is from your perspective. So naive RAG is just, let's just go off and search. We'll use the LLM to interpret the question, then we'll go to a data source, and then we'll retrieve that, and then we'll make a conversation with the LLM, right? And then, but that had lots of drawbacks. So what was the next iteration or the next evolution in terms of
so of course, like the more advanced RAG contains like things like re-ranker, like so the system that actually takes model that actually takes the query, takes the retrieve chunks of data, like I don't know, 10 most probable or something like that, and then compare them and choose the answer. This is something that can increase accuracy. You can retrain and you should retrain embedder to fit your data. This is also something that the advanced RAG can have.
Tell me more about that. What's the business?
Yeah, this is like currently we have really nice embedders. So simply models that changes chunks of data, like text data, to just embedding, right? And then
back to a mathematical representation.
Because
all LLMs use operate, they're mathematical operators essentially, right? They operate on numbers rather than words, and the words are converted to numbers. So we convert our text to a vector, right? And dimensional vector, right? Lots of different characteristics. And then we bring that into the vector space. That is called an embedding, right?
Yeah, exactly. So initially, we just used like the best embedder that were on the market, but like, I don't know, 1 year ago, the embedders were not really good. So every time you wanted to build a like highly accurate RAG system, you needed to retrain this embedder with your data simply. So in a way, it will put embeddings from question and proper answer close to each other and wrong answer far from each other, right? So this is the goal of this embedder. Currently, we have like new embedders like E5 from Google, which is pretty nice, but still you can gain a lot of accuracy if you retrain the system with your data, right?
When you say train it with the data, what we've done is we've ingested the content along with metadata. So had a knowledge architecture that provided additional tags or additional features essentially of the content for an enriched embedding. So when you're bringing it in, this is why knowledge architecture is important, right? This is why knowledge bases are important and metadata is important. If you have these things tagged with the right product model, right, and the right troubleshooting step and the right, whatever the error code is, right? Like I use that specificity to say an LLM will not know those things unless you tell it. And the way you tell it is by tagging the chunks of content before you ingest it. And then when you ingest it, you're bringing in the additional signals from that knowledge architecture to improve the ability for the LLM to make a distinction between a good and a bad answer. Does that make sense?
Yes, of course. This is one of the techniques that you can use to increase the accuracy, and this is also why you still need like good engineers who are aware of different techniques and can analyze your data, check which technique could be applied here, because it is not always the case that you can create some metadata or you can filter out some data during retrieval process. Sometimes it is possible, sometimes not. You always need like good people who knows where to use which techniques, right? So yeah, but yeah, this is one of the techniques that can increase accuracy of the embedder system.
You started to pull on a thread earlier around asking about the models and are you taking a foundation model and doing your fine tuning against that? Are you creating your own model? Are you doing continuously fine tuning on top of those models? Because it seems to me, to Bartek, that there's this super art form or combination of what you're talking about where you have potentially human in the loop, right? Or the validation of the data in the beginning. And then you have this notion of just the ability to figure out what to do with the model itself and what model is going to work the best and all that kind of stuff. And then also then the fine tuning and or the continuous fine tuning that goes into it. And do you need to add a human in the loop, right? Because I think what we're also talking about is it depends on the use case as well, on how those combinations need to come together. Will you talk a little bit about that? Because I'm assuming you have some models in production and going from POC to production, you've had to learn a lot of these different types of techniques that need to be applied.
Mhm.
So I don't know if you have some use cases in mind as examples.
Yeah.
What does that look like in terms of pulling that art form together?
Yeah, so like you said, like every use case is different, and you need to apply different techniques. For example, we currently for one of our client, we work with probably the most advanced search engine in podcast environment. So for a company called Podimo, we develop like the search engine, and the one thing that we needed to do there is, along with the classic RAG system, we needed to create fusion with keyword search, I would say, right? And the second thing we needed to also take into consideration is the way people usually search podcasts. So they usually do it in a Google-like style, I would say. So they, for example, write half of the word because Google will know the answer anyway, right? So also you need to cover things like that. So depends on the use case, you need to use different techniques, but more important is that you need to have these users in the loop, right? So you need to check what they actually write to your system, in what way, what they are looking for, and you need to adjust your system to your users, right? Because like for RAG system to be successful, you need three very important things. One is accuracy, of course. Second is latency, because you can easily create accurate system that will be really, really slow. You can put a lot of different models, double checks everything and stuff like that, but you will wait 15 seconds for the answer, right? And it will make no sense. And the second thing is really nice user interface. These three things is extremely important to make system user friendly and actually to make people use it. Because without it, even if you have highly accurate system, they won't like to use it. And actually people are the biggest barrier right now, right? Because sometimes of course there are people that wants to use the most advanced technology and they will use everything even if there is no sense of it. But there's a big group of people that simply don't like changes, right? And to convince them that they should use AI technology, you need to create a system that is accurate, super fast, and really nice in terms of interface, right?
I love that we have these like 70 billion parameter models, these 250 billion parameter models and stuff. And to your point on latency, I had a customer I was working with that decided to throw their entire product catalog, e-commerce site, and throw their entire product catalog at the LLM because they might have a search about one product. Super inefficient. But because the parameter window was that big, then they could do it. But, this is kind of an add-on to that question is, so also how do you balance cost optimization in there? Because part of that is I can slam and cram this against these large models all day long, but it's so expensive as well. And I would say, for me, that is that add-on to the user experience is how do you also make it so that it's optimized so that you can utilize it for billions of people or whatever the use case is and not kill yourself.
Yeah, so of course, like quantization is one of the strategy that makes system extremely fast, and you can actually apply double checks and re-rankers and other techniques only if you are able to quantize your model and you still can achieve good results, because without this system will be too slow, or it will not fit to your memory, or you would need to apply like a huge machine that has a lot of memory to handle your system, right? And if you would like to make your system scalable, serve to a million users, you definitely need to do quantization of your model, yeah, and queries and everything, yeah. And unfortunately, these models are very sparse, so the embeddings are very sparse. So quantization doesn't harm it too much, yeah.
Yeah, it's good.
So we talked about naive RAG. We talked about advanced RAG. Do you want to talk a little bit about modular RAG and your opinion of how that works and how effective it is and so on?
Yeah. So I would say that this is definitely.
Yeah. So
yeah, the definition. So I think that this is the most unmature type of RAG, that especially in terms of like a production use case where we can see how it works in production. But yeah, this system contains simply a lot of modules. For example, it not only looks for the answer in your knowledge base, it can search in the internet. It can combine those two sources. You can add other sources, apply re-rankers, like yeah, you do fusion from different types of RAGs actually, and the issue with it is that it all makes it slow, right? So there's not much use cases, I would say, that you can sacrifice latency for a higher accuracy. Of course, there are use cases like that, but I would say that 95% of our projects are rather system that needs to work really fast, right? So there's no way of doing modular RAG in that case.
So we've been using it a little differently. We've used it as kind of using templated prompts and programmatic prompts that are cycling through data and using modular RAG to ingest lots of different data sources. So it becomes more of a batch processing tool rather than a real-time retrieval tool. And what that is doing is it's using it to improve the quality of data. So we have one use case where we had very, very sparse data on product record, and then we enriched it with SEO terminology, with a richer product description, with additional attributes, categories, keywords, and then made that audience specific. So it was a good use case, but again, it's a different use case because it's talking about using it not in a real-time fashion, but more of a batch processing fashion. And I guess from all those agent approaches too, right? Because you're using an agent to often do a particular process.
Yeah, like the issue you describe, like the data you described seems very complex. So it's probably good use case for modular RAG to use to solve this issue, right?
So tell us a little bit more about you, what do you do for fun, and tell us a little more about your journey of how you got to what you're doing.
Who is Bartek?
Go ahead. Sorry.
I said, yeah. Who is Bartek outside of AI? And maybe you're an AI.
Outside of AI, I don't think there's any Bartek outside of AI. I would say that my hobby is like I said, I like to write models on stock exchange, right? So to play on the market and stuff like that. So this is actually my passion for a very long time, and I'm still writing my own models, applying new techniques. This is also actually the way I'm staying up to date with the current technology, right? Because now in my role, I'm far from the coding and I'm more close to the business, but I really like the technology and I need to be close to it to be effective in my current role. So this is also my playground where I can apply, I don't know, new reinforcement learning techniques and stuff like that. Yeah.
So what do you think of then all these AI bots that are out there? I mean, obviously most of them are going to be pattern recognition, but I love it. You see a lot of rhetoric and a lot of folks that are out there. Hey, look at my AI bot. It's made me so much, thousands of dollars per month on these bots and everything else. And I can only imagine that it's literally looking at the patterns of the candlesticks and everything else and just trying to see when leading indicators, lagging indicators, all that kind of stuff. I don't know what your thoughts are there. It's just, it's one of those that I watch too. And I'm like, a little suspect, but at the same time, I think you have to build it yourself. Go ahead.
Yeah, so I'm in this industry for a very long time, and I don't believe in any kind of statement like that. I know a lot of people who created, like, I wouldn't say bot like that, but strategies that works. Then they don't tell anybody about it, right?
Yeah, of course.
The only way you would like to tell more people that you have successful strategies because you want to take their money and invest their money, right? But this is for I would say big hedge funds and stuff like that. So this is of course obvious. But if we're talking about like proprietary trading and day trading and stuff like that, when you just like have your own strategy for yourself, you don't share your strategy. Simply, you don't share your results. I don't think I know. Probably, maybe I'm not up to date with the X platform and the people who and their claims there. Maybe there are some superstars that just like to be famous. I don't know, but my experience is that people who knows how to earn money on the market stay silent.
Well, it's fascinating. So thanks for your insight.
Quick question. So sometimes I like to ask this: if you were able to go back to yourself and when you graduated college, is there any advice you would provide yourself looking back at your life?
Yeah, I don't know. It's a hard question. I did it a long time ago. I don't know if I think current world is different, right? But yeah, probably the thing that is important is that I'm working now in the industry that is totally different than my educational background,
sure.
right? And this is something that probably will happen to a lot of folks that currently graduate, right? Because AI will like change the way we work simply. So what I would recommend to people is that don't hesitate to change your background. If you see some potential somewhere else, like go for it, right? This is one thing. And second thing, if you feel that you can do something good, also go for it, even though you are getting refused many times, right? Before I started my career in the New York Stock Exchange, I did a lot of strange things because it happens to me that I entered the labor market during the financial crisis, 2007. So it was really hard to get a job in finance that day. So yeah, I needed to do a lot of like really, really simple jobs. And actually I could stay there because I got better and better at that. But I know, but I had just like different dreams. So I decided to pursue it, and I would recommend anyone to pursue it. Yeah.
What's the worst job you ever had?
The worst job I ever had?
Yeah.
Oh my God. Yeah,
You're
I
coming
cleaned
up
a
with
muffin. I cleaned a muffin factory.
I shoveled horse shit. This is my job. Yeah. Keep going.
Yeah. Okay. So I think I was the worst job I had was I was working in a huge like mail center, and for the whole night I was like packing the big cars with the packages, right? For the 12 hours, right? I remember this was probably my first job after I graduated the college.
Kind of like working for Amazon today. Right?
Yeah, exactly. So it was it was exactly like that. Yeah, it was very hard. It was very hard. Yeah.
So let's see where people can find you. You can go to stxnext.com. That's the company. And then you are on LinkedIn, and it's just BARTEK dash Roszak, ROSZAK. That will all be in the show notes. And Bartek, I want to really thank you for your time today and for sharing your expertise.
Yes. Yeah. Thank you very much. Thank you for having me. It was a pleasure.
It's been great. And thanks to everyone who's listening. And thank you, Carolyn and Chris. And again, Bartek, it was great to have you, and look forward to continuing our conversations. Thank you.
Thank you very much.
Thanks, Bartek.
Visit Earley.com to find links to the full podcast on all audio platforms to listen on the go. Thank you for watching. Contact us today at info@earley.com.